Alright, here we have a convex lens. It's thicker in the middle than it is at the ends. You see that horizontal line going through here is still the optical axis, just like we did with our mirrors. Where the horizontal line crosses that vertical line, we have we call the optical center of the lens. And then the vertical line is actually going through there is what's known as the center line of the lens. So that's the basic geometry of the actual lens itself. Alright, so what I want to do here is take a ray of light parallel to the optical axis. At the surface then, it's going to refract. Now, in order to figure out where it refracts, we need to have a normal line. So you put your protractor up along the left edge of the actual lens itself. This is how this was actually drawn on the paper. You'll notice that you can trace around. It's just part of a big circle, basically. You just drew one little piece of it. So there's a center there. The vertex of your protractor will give you the center. So you mark that off on the optical axis. And so now we can draw a normal line with that curved surface, which is going to go through the center to the surface itself. Again, if you just put a dot in your protractor, put a mark in that little hole right there where the vertex is, that'll find your center on there just fine. So now we've got a normal line. This worked out to be about 23 degrees. It's not really important what your angle is, but the refraction then that takes place has got to make it bend towards the normal, or the angle of refraction there between the light ray and the normal needs to be less than 23 degrees. But only draw it so that it gets right to the right surface of the lens. So the red line represents the light inside the lens. When it gets to the right surface, it'll refract again. So we need to find a normal line so we know which way it goes. Go ahead and put your protractor back on there. Mark at the vertex of your protractor where the center of that right surface is. Again, it's just part of a circle. It would be over here on the left side of the picture. We just drew one little piece of it to make the actual lens itself on the paper. So there's your center. We'll go ahead and draw another normal line where the light leaves. Now, since it's going to speed up as it leaves, it's going to have an angle larger than it came in at, or bend away from the normal. So you can see it's bending away from that yellow line. In this case, it takes it right down through the optical axis. So if we do the same thing from the bottom, you can take the time to draw the normals if you want to, but the idea is it's going to bend in this manner. When it does so, it'll cross the optical axis, the same point the other light ray does, which is the focal point, just like on our concave mirror.